Right, welcome back to day 17. Yesterday I got cut off by a power cut, so I haven't actually finished 16. I'm gonna have to go back and do that afterwards. So I was also kind of stuck on 16, so it might be good to take a break from it and come back with a fresh head. Well, let's hope 17 is not too long, otherwise I won't have time to squeeze both in and I'm gonna fall behind. Alright. Pyroclastic blow. Your handheld device is located at an alternative exit from the cave for you and the elephants. The elephants that we didn't actually save yet. The ground is rumbling almost continuously now, but the strange valves bought you some time. It's definitely getting warmer in here though. The tunnels eventually open into a very tall, narrow chamber. Large, oddly shaped rocks are falling into the chamber from above, presumably due to all the rumbling. If you can't work out where the rocks will fall next, you might be crushed. The 5 types of rocks have the following peculiar shapes, where hash is rock and dot is empty space. Okay. Okay. First, oh god, this is Tetris. Okay, first the line shape falls, then the plus shape, so on. Once the end of the list is reached, the same order repeats. The rocks don't spin, but they do get pushed around by jets of hot gas coming out of the walls themselves. Alright. We're going to simulate Tetris, but we're not actually playing it. Good, because that'll be more complicated. The tall vertical chamber is exactly 7 units wide. Each rock appears that its left edge is 2 units away from the left wall. And its bottom edge is 3 units above the highest rock in the room. Or the floor. After a rock appears, it alternates between being pushed by a jet of hot gas 1 unit, and then falling 1 unit down. If a downward movement would have caused the falling rock to move into the floor, then it stops and stays where it is. Okay. And a new rock immediately begins falling. Yeah. To prove to the let me guess, are they going to have to implement, at some point we're going to have to implement the line breaking algorithm, which removes the line. To prove the elephants your simulation is accurate. We have caviar flavored crisps, by the way. This is twice as expensive as the regular crisps. So, I've had truffle crisps. It's alright. How do I open this? Damn it! I want to open this now and... You need scissors? Oh, come on, that's nonsense. I should be solving it. Proves to the elephants your simulation is accurate. They want to know how tall the tower will get after 2022 rocks have stopped. before the 2023 rock begins falling. Alright, 2000 is not that big a number, so just having a think. So the height increases basically, so either we just make it really big to begin with, or just make it big to begin with. Otherwise, we have to make it dynamic, which will probably mean we have to make it upside down, given the way Python works. In this example, they actually use a very large number of rocks, so we can't actually see the answer here, but okay. All right then. So I see. So the input is literally just the hot gas. Well, how big is this? $10,000. It's big enough. That's the important point. All right. So we probably want to the first thing is all right. Let's make the grid. Trying to. It says what? Trying to find the. Okay, this. Seven units wide. And we want to keep track of the highest rock in the room at all times. So right now, the highest rock is the floor. You know what? I can think of a way to do this efficiently without storing our whole grid. You just store the coordinates of the topmost rock in each column. No, that wouldn't work, because you can have some weird shapes which are like concave, and you could move your piece down and into them. So we do actually have to simulate the whole thing, unless we simulate a perimeter around them, but we don't need to do that. So let's say grid equals height equals, so we want to put at most 2022 rocks, and our pieces are at most like 4 height. Let's say 10,000. That will cover everything. Width equals 7. Grid equals dot okay, so we just make a really tall tower. Highest rock equals so it's the rock level, the ground level 0 or -1. I would say it should be -1. Because when there's a rock on level 0, it's the highest rock, so okay. And then the other thing we need to do is program in the shapes. So shape on equals how are we going to do this? Also, damn it, where's my air conditioning remote? Right. All right. So, should we just describe the shape as a set of coordinates? So we've got the line. paste these here for now. So shape 1 equals, let's say, 0, 0, 0, 1, 0, 2, 0, 3. Shape 2 equals 0, 0, 1, 1, 0, 1, 1, 1, 2, 2, 1. Shape 3 equals 0, 0, 0, 1, 0, 2, 2, 1, 2, 2. Zero, zero, 0, 1, 0, 2, 0, 3. And then finally, hope I get all these right, because otherwise I'll screw everything up. 0, 1, 1, 0, 1, 1. Shapes equals so we want to define get shape and we just say while true for shape in shape 1, shape 2, shape 3, shape 4, shape 5, yield shape. So it's just infinite. It goes around in a circle, but it always gets us the next shape. Okay. So far so good. Got this. Okay, I like what I've done so far. It's very orderly. All right, so next, so what happens first? We spawn in a rock. All right, let's pull in the input as well. With open input, so moves equals list, just I don't know, line dot strip. We've just pulled that out, so we've got the input now. either left or right. Okay, so the number of rocks resting is 0 right now, while resting rocks is less than 2022. So here's all the steps we do. We spawn in a rock. And its position will be, oh, okay, hang on, so hang on. Right. Yeah, we're spawning spawn rock. So shape equals get shape. That'll get the next one in the queue, circular queue. Wait, I wish they had a summary of this. I have to scroll all over the place to find the relevant details. So what actually happens first? It spawns in. So that its left edge is 2 units away from the left wall, and its bottom edge is 3 units above the highest rock in the room. So the bottom left corner, spawn point equals. So the row will be the highest rock plus three. Does that make sense? So if it's, so to start with, it will end up being spawn point equals 2. That's not right, hang on. No, that's right. Because the floor is -1. Yeah, okay, fine. It just seems weird. Alright. Spawn point equals highest rock plus 3. And the left edge, 2 units away from the left wall. So just oh. So when they say 2 units, they mean 3. They actually mean the 2 unit gap. Okay, that's badly worded. 2 units away would normally mean 1, 2. But they actually mean 1, 2, 3. Oh, and the same for... Three units above. 1, 2, 3. Yeah, I don't agree with this wording. So they actually mean 4 here. That's not 3 units. There's a 3 unit gap. Empty spaces, but I don't agree that's 3 units up. And now we got 2. Yeah, this is really weird, the way they worded this. Okay, fine. 4, 2. That's where the bottom left corner is. It alternates between being pushed by a jet of hot gas 1 unit. So, hello DJ. Yesterday my stream got cut off. There was an explosion somewhere near my building, and then all the power went off. And then I looked out the window, and all I saw was just a huge flock of birds flying away from said explosion. So I thought, just screw it. I went to the shopping mall for a few hours and came back. So I haven't finished problem 16. I'll have to do that afterwards. So now we're doing Tetris. Which is interesting. We're basically simulating Tetris. So a rock, one of these pieces. There was an explosion, so I went shopping, yeah. I assume it was a transformer or something. Pretty normal thing to happen in Thailand. Power cut out pretty easily, especially when I was living on the islands. You could have entire island-wide power cuts sometimes. One time it was because a chicken got caught in the transformer, and I saw the photo on Facebook of it. They pulled the chicken out, and he was like exactly like it looks like in the cartoons when a cartoon character gets fried by electricity. It's like feathers outwards, and he looks very burnt. Yeah, absolutely something out of the cartoons. Guess the chickens just want somewhere nice and warm to lay their eggs, so they go to the transformer. Alright, so a rock appears, gets pushed left or right, moves down 1, move left or right, move down 1. Okay, so we have to figure out where it rests. This is just kind of simulation. I don't need any clever algorithm yet. So we spawn in the rock, and then let's say gas iterator equals 0. Move. So we now want to find out which way we move. Also, while true. So we keep doing this. We say move equals gas iterator. What am I doing? No, we want moves gas iterator. And gas iterator plus equal 1. So we've got our move. It's either a left arrow or a right arrow. Dx equals 1 if move is else -1. New shape equals hang on, so the rule is if we ever clash with a rock, then it doesn't happen. Okay. But if it's downwards and it clashes with a rock, then it terminates movement. So here, okay, we need to create the new shape. So it's going to be x plus dx y for xy in shape. So we're basically just adding dx to every coordinate. Then for point in new shape, if grid point y. Okay, this is going to be an upside down grid. It's just easier to code this way. Point 1 0 equals hash break. Else, so if we break out of this, if we don't break out of this for loop, that means there was no clash. This new shape is in a valid spot. Then we replace shape with new shape. So this was gas movement. And then we do the downwards movement step. So new shape equals y minus 1 xy in shape. Again, we do this, but this time if there's a clash, then okay, we need to say done equals false while not done. Done. So if there's a clash, done equals true. Break. So done equals true. We just leave shape where it was. We don't replace shape with new shape. We want to increment resting rocks plus 1. We want to highest rock. We want to update that equals the max of highest rock with the maximum y value of the shape. So max y or for the highest rock coordinate for the shape. And they want to break out of this for loop. Otherwise, we just update the shape to be new shape and rinse and repeat. So if this is done, then we'll break out of this. check how many resting rocks, and then we do again with the new highest rock value. Okay. Do all that. This is probably not going to work yet, but when we're done, what exactly do we want? We want how many units tall would the Tower of Rocks be after 2022 rocks have stopped falling? So they have a weird indexing system here, so I'll have to actually check this against the example to see what they want, because I could take the Y coordinate. I think they want the Y coordinate +1, so we'll do that. Hello, Ku. So print highest rock +1. Alright, I don't know if they want +1 or not. I'm just gonna have to test it on the example. Let's try running it anyway. XY in shape. $40 late, you must be nearly done. Maybe with part 1. I just had to simulate Tetris. Doesn't seem to be hard. It's just a simulation. And the numbers don't seem too big, so why doesn't this... So shape is a tuple of pairs. Too many values to unpack. How can shape ever be... Print shape generator object. Have I not done... Oh, that's not how you use generators. Shape equals get shape. How does this work again? It's, you call next on... Man, I even used yield in one of my previous ones, and I can't even remember how to do it. It's called next, but not on this, dude. Does that work? Right. Move equals moves, gas, iterator. String index out of range. This thing is like 10,000 long. We're not stopping, that's the problem. While resting rocks is less than 2022. How many moves could we... It doesn't... Do we have to go around in a circle? Is this a circular list? If the end of the list is reached, it repeats. So I guess what we actually need is something like this. Get, move, for move in moves, yield move. There must be a shorthand way of doing this. To make just a circular list, and then alright, anyway, so we want move equals next of I think there's some ITools magic to do this too. I think I've got to learn various ITools things again. There's definitely lots in there that I'm not using enough. Okay, this doesn't terminate. I need to see what it's looking like. Print resting rocks. ITools.repeat my moves will repeat it infinitely. Oh, that's good. With 0 resting rocks, so we're stuck on the first rock. Alright, I'm definitely using this yield thing wrong. I could switch to using our ITools, but first let me just look up what I've done wrong here. So Python generator yield. But I shouldn't be seeing generator objects in the output here. I should be seeing the actual object, the shape, like the tuple of tuples. I think the problem is I'm not using the next. Ah. Wait. Yeah, next is supposed to give you the actual item. Call next on the iterator to get the next item. I don't remember ever doing that before. Okay, so iter at the beginning to get an iterator object, then you call next. Iter get move. Hang on, I'm looking at an example here. yield So the example they've done here was gen equals. Let me just try what they've done here. I equal. Fine. So they said the only difference I have with this example is this gen equals get shape. I suppose, I don't know, and then they go next gen. Is that different? The example I'm looking at does that, and it actually gets items out of it. Let me look at another example. You need to assign get move to a variable. So, okay, yeah, the same thing as I did with get shape. Well, I thought it would still... Okay. Fine, so let's... shape gen equals get shape, like that. Yeah, this is... I definitely need to use item tools instead. This is more work than necessary to make an infinite list. So shape equals next of shape gen. Move equals next of move gen. I don't... I'm still not getting the actual contents. And shape. Try move gen equals iter get move. Let's just leave move. Now, printing the shape. No, it's the same. Oh, stand what? Alright, I need to find another yield tutorial here. Well, I need to settle this understanding of yield because that's important knowledge. But yeah, I will in the future switch to item tools. Yeah, but I can't really use a for loop here. I need to be able to call an item when I'm ready. Find generator, gen object equals generator. Next. me try taking one of these examples and pasting it in to see if I actually get what they say. Okay, Fibonacci. No, but that's not using next. Okay, just confusingly written guides. Let's look at another one. I can't find any clear guide on this. I mean, look, the example that I had, the example that I was going off to begin with is this. Let's create a new file here. So that's just returning the numbers, and then they just do this. All right, print next gen. So that works. What? Why does that work? This works for me. Hang on, let me. While true for shape and shapes yield shape. So is there something different from shapes? Your shapes is a list. That shouldn't matter, I guess. Let me try moving the shapes to that new file, or yeah, so let me see, what was the first thing it printed? Okay, let's just take that out. It is replacing shape, so that could be what is the first thing we see. Okay, it works. It's changing it to something else later on. So the only time I change shape is when I set new shape equals. Oh, damn it. Yeah, I see the problem now. That's a generator. Tuple, I guess. That's it. Point 1, point 0. Okay, let's print what shapes we're getting. I'm going into negatives. What? Oh. No. This one. I'm also not checking if it's going out of bounds, because I was assuming the floor was rock, but it's not. The floor doesn't exist. If... Okay, so when we move it horizontally... We should have made it a grid with... I could change it to have a grid with rock columns and a rock bottom, just to... Or I could just say... If... Okay, we need to say if point x is less than 0 or point x, if the x value is less than 0 or the x value is greater or equal to 7, or it hits rock. Similarly, if point, so now it's the y values. So if point 1 is below the ground, or it can never go up, so... Alright, let's try that now. Okay. Got something. What? 4? No, that can't be right. Oh! The one important thing I've forgotten to do. Actually put the shape in the grid after we've found where it's supposed to go. I've never actually changed the grid. So we're just squashing all the Tetris pieces into the same bottom row. Alright. So when we get shape, for point in shape, we just want to put that in the grid. So grid point 1 point 0 equals rock. That's it. For row in grid, print Completely empty. We're not adding anything here. Oh. We're using that variable? I guess that's messing things up. The ID did warn me there. Now what? Oh, because it's upside down. Because I'm increasing from the top. That's fine. I can do it that way. I just need to... What? Well, we can print it the other way around. Just see what it looks like. Okay. What? So the first shape we get is the horizontal line. So already something is wrong because, oh, have I got the X and print shape? One zero one one 1213. That's already wrong. It should be on 00010203. Wait, what? No. Why is the X value 1111? This has changed to a vertical line. Ugh. Alright, where have I redefined the shapes? New shape equals x plus dx, y for x, y, and shape. So let's preserve the x and y's. New shape equals x, y minus 1 for x, y, and shape. That's preserved. How did it end up vertical? Also, I don't need this iter anymore. Alright, so... Stop printing the grid. Alright. It's no rocks. 10111213. How does that happen? Alright, well, So new shape has at some points rotated. X, Y, X, Y, X, Y, X, Y. Alright, let's first just keep this here. Just do 2 pieces, alright. So we want to start printing the shape here. So that's correct. 0, 0, 0, 1, 0, 2, 0. No, that's wrong. How did it start vertical? What? Is it wrong from the very start? No, that is what I typed. 0. Oh my god, it is wrong from the very start. What? Oh, no. I was using... Oh. I was using the... I wasn't using XY coordinates, was I? I was using... Oh, this is the problem when you use both XY coordinates and row column coordinates. Oh, that's the problem. So all of this is correct under... So I just need to... Okay, so it's IJ, not XY. Alright, fine. So every time we've used XY, just make sure we... So it'd be... So for I, J and shape, want J plus DJ, I. And we should actually be using them in the right order. I was using IJ from the start. So if point new shade, if point 1 column okay, and then we've got I J I J, and we want I minus 1. And the highest rock is the max I value, i.e. row value, for I P0. If I actually changed everything correctly. So that looks sensible. Right, let's take off the cap. Say, now what? Where are all these pieces? Oh yeah, the spawn point is needs to be swapped around as well. Every time I see a pair, it needs to be swapped, basically. So it's going to be... No, that was right. That's I value. That's J. That's fine. There's something else that needs to be swapped. Oh, I've made such a mess of this. Alright, let's check the shapes again. So we've got horizontal line. So that's 0th row, 0, 1, 2, 3 columns, okay. Then we've got plus symbol. 1, 0, 1, 1, 1, 2, 2, 1, yeah. Then we've got vertical line. Oh, damn it. At this point, No, this is fine. 0, 1, 0, 1, 0, 0, 0, 1, 0, 2. 0, 0, 0, 1, 0, 2. 0, 0, 0, 1, 0, 2. Then it should be 1, 2. 2, 2. Okay, that's a mistake. That shouldn't... There's more mistakes though. And now I've repeated the horizontal line. I just kept deciding to change between I's and J's and X's and Y's. What a mess. So it's 1, 0, 1, 1. No. No. 0, 0. 1, 0. 2, 0. 3, 0. And then shape 5, that's a block of 4, so that's fine. Alright, but that's not the problem though. It's just the shape. Okay, the shapes were wrong. Now what? Alright, so they're all going in the same bottom rows. What is going on here? Where's my vertical line? Yeah, okay. That's the vertical line. So they're all ending up wedged into the same place. Oh, I think this spawn point. Damn it! I forgot to spawn them in the right place as well. Alright. Hopefully this will be the last change. So shape equals tuple of spawn point 0 plus I spawn point 1 plus j for I, j in Next of shape gen. I forgot to actually place them up there, so they're always spawning on the bottom row. There we go. Now that looks plausible. Big old tower. What did we get as the final result? 3047. Alright. Not the right answer. Too low. Fine, let's try the example they've given now. This were the pattern. What do we get? 3168. And their answer? 3068. 100 off? But I think that's just coincidence. It doesn't look anything like that. So why... The horizontal line was the first thing to fall, so why do we not have a horizontal line at the bottom? This is just a mess. Zero 4 1 3 1 4 1 5 2 4. What is that shape? No. The plus shape. Oh, this isn't right. I just can't get these shapes to Oh, did I not remove that line? Oh, that's probably what's screwing everything up. It's taking every second shape. 3068. There we go. Alright. Alright, this better be the answer. 3184. Correct. Oh, that was so terribly done. I just made so many stupid mistakes. Part 2. What's part 2 going to be? This is a really short part 2. The elephants are not impressed by your simulation. They demand to know how tall the tower will be after. What is that? 1,000, million, billion, trillion. The trillion rocks have stopped. Only then will they feel confident enough to proceed through the cave. How tall will the tower be after a trillion rocks have stopped? I mean, I was thinking of just storing... Oh, okay, we can't, no matter what, we can't fling a trillion rocks down. But it probably would cycle at some point, because we've got a big set of moves. And a fixed set of pieces. So if we just find the point at where we start from the first Tetris piece again, and we start from the first move again, and just hope that it'll start looking like it did before. Because what could... It's definitely going to cycle, it's just not clear where it will cycle. Even if you reach... So at the very beginning, we've got a flat bed. Then, after you've gone through this list of moves, when you go back to piece 1 and move 1, after however many moves it takes to get there, what will the bed look like? Not quite flat, but you now have a horizontal piece. It's not it, so for all intents and purposes it might be like as if it was flat, because there's not many places it could just squeeze in. Well, we can actually test this, can't we? So... One, two, three... So there's 5 pieces. And... how many? Hang on, where's the line number? Okay, so it's... So... to the end... 10091. Let's just... Let's stop printing stuff now. Alright, let me just confirm that. Print length of moves. Don't print anything else. One 0091. So all right, so after basically we want to find the point at which we have Tetris piece 1, shape 1. So let's stop using generators and just go back to using indices which reset. So that way we can actually keep track of where we are in the shape list. Right. So we want shape it equals 0. Move it equals 0. So when we get a shape equals to in shapes, shape it. So we've got a shape, and now shape it equals shape it plus 1% shapes and then when we get a move equals moves move it plus 1% length moves. Alright then. Let's check that that still works. 3184, yeah, okay. So we're no longer using generators. Now we know exactly what the iterators are. So now I want to say if shape it let's say if resting rocks is greater than 0, so we're not at the beginning, and shape it equals 0 and move it equals 0, I want to print the grid. and just break out of that. So I want to have a look visually to see what this looks like after we've kind of cycled through and we're starting with the same shape and moves. If resting rocks is greater than 0, shape it to 0, move it. Okay, it doesn't cycle within this time frame. That makes sense because got a lot of moves here. Make this height a bit. Oh, don't make it bigger yet. Okay, I don't know, 10,000. Just want to find the point at which it recycles. List index out of range. Okay, make it bigger. Well, not that big. We're not going to be able to. Just do it. Let's see what it looks like. Doesn't happen. Wait, what? Shape it equals 0, move it equals 0. It should happen on average every time we go through, unless it's actually in a cycle and it can never... No. What? It's not right here. So resting rocks is greater than 0. Else, I don't know, print, shape it, move it. What's going on with these iterators? So, okay, the grid is not big enough, fine. Let's go to 50,000 then. $7,000. Need to go higher. So we don't want to print this whole grid, it's too big, but we can print. Say the final 10 rows. Alright, let's increase this to 100,000. Still not cycling. Oh, because I'm restricting this. Hang on. Keep going. Need a bigger grid. Damn it. It doesn't cycle. Am I thinking about this in the wrong way? Maybe I'm just wishful thinking. So when it gets to 0, it's now on iterator 18. I just keep going until I actually find a cycle, because once I do, then I'm sort of solved it, haven't I? Right, we don't actually need to terminate. Just true. What am I printing here? Take that out. Grid's not big enough. We actually need a rolling grid, don't we? Is there a better way of doing this? So we don't need to... I'll just push it to the limits, but this is kind of bad. We don't actually need to store all that grid, we only need the last few spaces, because a piece is never going to fall much further than that, so... So, grid actually needs to be a double-ended cube, sort of. No, not double-ended cube, but a linked list, essentially. Yeah, a double-ended cube, but then we can't access its contents easily. Right. We've got... Where's this light coming from? Right, this approach is not going anywhere. Yeah, okay, it's crashed. Yeah, the grid's not big enough. So yeah, this is no good. Let's just stick to 1000. Let's have a look at this again, see if there's a pattern here. While resting rocks is less than 2002. Alright, so we get this horizontal line. You get interesting shapes. I'm tempted to just store the top of each column, the coordinates of the top of each column. But that's not strictly enough, because something could fall. You could have a sideways gap and something could fall and squeeze into that gap. Does it ever happen though? I don't know. So we want 1 trillion rocks. How tall the tower will be. I mean, this small example is easier because there's a shorter moves list, so it's not going to be hard to find a cycle there. And these puzzles are getting harder, and I still need to do 16. So I think this vertical line. Oh, I'm not even showing the. See, this vertical line could now, in theory, fall quite a long distance down on the right, except the moves don't allow it to, but still. Maybe I need to keep going with this cycle idea. I'm just need to actually find that cycle. So we don't need to record as much stuff as we're doing. So firstly, grid. We probably don't need to store any more than like let's say the height is 10. Right, so we're just storing 10 rows because I don't think you need more than that. And every time we've placed a piece, we want to say how much did we change the let's rewrite this stuff here. So let's take that out. So I want to say if so if it's now resting, we want to work out highest point on shape equals that. So that's the highest point on the shape. Or I in range. So we want to have a look at the grid from this point downwards. Damn it, why? Okay. I in range. Highest point on shape. Oops. If hash in grid I, that means there is a rock in this row. And so what am I getting here? I'm getting the old highest, and highest point on shape is the new highest. So height increase equals highest point in shape minus I. If height increase is greater than 0, that means we actually increase the height. Highest rock is increased by that. And for in range height increase, we actually rotate the grid. So grid delete grid, delete the bottom of the grid. We probably will never visit that place again. Grid dot append dot for j in range 7. Okay. Hang on, we should put the shape in the grid first. So now our grid is always of height 10. We just keep, every time the height increases, we cut off a few rows and put a few rows on top. That maintains it. The problem though is, where do we spawn the rock? We can't spawn it there. If we do this, it'll just crash. Yeah. Let's make shape minus I. So I in range. I is not defined. Huh? Should be getting I from this. Well, maybe it's because we're not using the highest rock yet. So to find the highest point again, so we need to do this. Okay, well, I in range, let's say length grid, starting from the end, finish at 0. So that should give us the new highest on this grid. So it's always gonna be between 0 and 10, not like a huge Y coordinate. Also, we can't use I because that's okay. 5, 1, 2. Now we've got a wrong answer. 4, 5, 6, 7, 8, 9, 10. Ah, because we're cutting off pretty early. So if Alright, if height increase is greater than 0, I also want to say if we've actually gone above 5. So if it's greater than 5 and height increase is greater than 0, that's when we start rotating it. And now we're... What? Spawn point equals I plus 4 to... I think we're supposed to set this to be -1. Shouldn't really, but whatever. Right. What's going on now? Grid point 0.1. So what is point value here? We're always supposed to be between 0 and 10. It's too big. What? Alright, I don't like this cleanup that I'm doing. Let's do it differently. Say every time... Alright. Let's take this out. So... I want to say oh, I don't know how to do this. It's such a mess, this simulation. Okay, what I had before was actually telling us how much we've increased the soft print point 10.1. How did we get 10.1? So if I increase this to 20. 3168 is fine. So a grid of size 20. Should we change? Take that out. Change the midpoint to be around, let's say 10. All right. 3171. I got a wrong answer now. What? 3171. How'd that happen? 10 minus 1. Yeah, but that's under... Yeah, that's fine. Wait, so for 5 it was the correct answer. 10 it wasn't. 167. What? This number here shouldn't matter, it's just... Sorry, okay, that should go out here. That should always happen. Only... Okay, now we should get the right answer. No. Highest increase. Okay. If height increase greater than 0, do that. I think it might be negative sometimes, so. Why am I only getting the right answer for 5 here? I'm not getting it for 5 anymore. For sake. Alright, I think the problem is at the very start we don't have any rocks, so we've got to say else I equals -1. I didn't fix it. $3,174. We're like 6 off. How did that happen? $202. That's way off. 8. 3,176. What's going on here? Basically, I want to say if it's gone over 10, that's too high, and we need to. Okay. Let's just do this instead. Oops. We'll do this independently of whether there's been a height increase or not. Well, that's made it worse. Looks like my stream is cut off as well. It couldn't take all this failing. Highest point. Let's say highest point. Range, number grid. -1, -1, -1. Else highest point equals -1. Highest point. Okay, so where are we using highest point? Spawn point equals highest point. I think that's not quite right. -1 plus 4, 3. So 1, 2, 3. Figure that out later. Now we don't need this. This point. All right, let's try that. 3182. I don't know. 60. This whole thing is a mess. I probably need to just nuke it all and start from scratch. Start from the top. Let's see if we are actually putting the first block on correctly. 1. That's correct. Let's go for 2. 4. That's correct. Now, when we put a new piece in, what we want is to the highest rock we update with the height increase. We put the rock in. That seems to be correct. And then highest point on shape. If it's greater than 10, we want to just shift the grid down so that it's less than 10, or equal to 10. So for range, we delete the bottom level of the grid and we put in a new empty row. Should be fine. All right, let's try putting in another piece. 7. 1, 2, 3, 4, 5, 6, 7. Now at this point, we add one more, it might tip. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, that's wrong because we should be rotating now. hour. So 11. That's not right. So 10. Oh no, that is correct because it's on 10. It's just on the right edge. Put 5 rocks in. Highest rock equals 11. That doesn't sound right. Where did we put the last rock? There. So for 4, looks like that. Okay. 5. For 5, no rock was inserted. What the heck? I think its spawn point is wrong as well. Spawn point. Okay, so highest point. Print spawn point. $14.2. Okay. It's the starting rock. Three, 2. Where does the starting rock spawn? I hate the wording here. So it's 0, 1, 2, 3. So the starting rock, that's correct. New rock appears, so it should be 1 space higher, really. 4-2. Yep, that's right. And 7-2, 10-2, 14-2. That looks correct. So what happens if I go to 2022? You went 8-2. What happened? Okay. So that's what it looks like. And we put one more piece in. Another explosion? No, I don't know. Just cut out briefly. This problem I can't. I'm not even doing the hard bit. I'm still just trying to make this actual grid. Coordinates are always wrong. So adding that junction piece. And that looks correct. That's where it would end up. That's correct. Okay. $3182. Where does that number come from now? 14.2, 14.2, 14.2. Well, why is it always spawning at 14.2? Could it be? highest point... Yeah, it should be. Because the highest point now is always going to be 10. Because we're shifting the grid to always keep the highest point at the top. So, a correct place for it to spawn. Hang on. The highest point is at 10, and every time it's not a 10, we shift the grid down to make it 10 again. Maybe this spawn point is not quite correct, so then the rule says and I wish they had a summary for this. Like, you have to read through so many paragraphs to find the relevant information. Its bottom edge is 3 units above the highest rock in the room. Okay. So that, but wait, they actually mean 4, not 3. Oh, well, they say bottom edge, so it's a bit... Okay, fine. There should be a 3 gap between the new rock and the old rock. 10, 11, 12, 13, 14. So this is the correct spawn point. 14.2, so we're doing different spawn points anymore. Maybe 182, it doesn't make any sense. What if I were to change this to be a bit bigger? 30. We'll choose the cutoff point to be, well, we can keep it as 10. 30 to be, I don't know, 15. 15. We want 5.9. It actually changes. Something is completely wrong here. First of all, we don't need to keep changing this. Say mid line equals height over 2. If we do 100, 3184. If we do 10,000, we should get the right answer because the grid's big enough to fit the whole thing in. Interesting. So we've got the wrong answer here, 3184. We're never rotating the grid here, so it's not the grid rotating that's causing the issue now. We're getting an extra... The correct answer is 3168, and we're getting 3184. So we're adding 16 somewhere. Height increase equals highest point on shape minus highest point. Highest point is the highest point on the grid. If height increase is greater than 0, highest rock, we add the height increase. If the new shape has pushed us above the midpoint, we do the rotation. Fine. Oh, it is 3184. I've been choosing. Oh, goodness sake. 3168 is the example. So how long have I been trying to debug this when I've actually been getting the right answer here? Alright, so if I go back to, let's say, 20. 3182. What? Now that's wrong. Let's go to 30. 3159. Alright, so no, I am getting wrong answers still. 3184. At 100, it's 3184. 101. I think we just need it big enough because some weird stuff happens in between. 80. 3184. So I think they actually have like a vertical piece going down a huge column or something at some point, and that's screwing everything up. So we can safely store, I don't know, 70. Figure out what was wrong. So basically, instead of trying to store the entire grid of all the Tetris pieces, I'm just trying to store the top 70 rows or so. Which I thought would be sufficient, but I think I think they are like dropping a vertical ladder down some really long column or something to make that kind of invalid. So 70 doesn't seem to be enough. 80 maybe. Yeah, I think they're being tricky and they're dropping some horrible piece all the way down. 80 seems to be okay. Alright, so we can store a grid of height 80. That's took me like an hour to just change from massive grid to a grid of size 80. Right, fine. We can now do stuff with this now, so I suppose I should double check this also works on the their example too. So I should be getting 3168 for this. $3068. Yeah, that's correct. Okay. Alright. So now what? I can't do. Alright, so what I want is to find a point at which shape iterate to 0, move iterate to 0. Okay, so we want to see what it looks like when we return to the first shape and the first move. And I don't know when this will happen. Just check 10 million, see how many, see when it happens. So now we're not storing a massive grid now. So that saves on memory. Doesn't seem to be happening though. Maybe we never return to the first shape again for the first move. Okay, stop. If move it equals 0, print shape IT. Do we even ever reach the first move again at this point? So that we start there. No, so let's find a cycle. If shape IT is 0, print move IT. Let's just see what happens here. So it's cycling, but it's kind of all over the place. And it's not cycling in a regular way. It skips 2 or 3 at a time because the way we do this. Well, that makes sense. Okay, fine. 2018. Oh. Have we found the cycle? 18. So its stable state is at 18. Let's see. Okay, so move IT equals 18. Let's have a look at it when that happens. So 2777. It looks like that. The next piece to drop is a horizontal line of width 4. Now it could drop here, but I don't think it does. So that's let's have a look at these moves. So we've got right, left. Yeah, so it is actually just going to plop down on top. And at that point, I think the whole process repeats, because I don't think we'll ever dip below there again. Let's just verify that. So, we want to print the number of resting rocks we have. Hang on, we're printing too much stuff here. $1750. So cycle is at 1750. Let's just check. So 6,000. Don't break. Just print. Find out how many times this happens. Okay. Alright, so we've got the first time this happens is 1750, then 3495, then 5240. What's 3495? Take away 750. So that comes 1745 later. And then the next one comes 5240. Take away 3495, 1745. So yeah, it is now going to repeat every. So it takes 1750 to reach the first stable point, and then after that we go 1745, 1745, 1745. All right, I'm getting somewhere now. What do we do with this information? Let's say at 1750, resting rocks will print the highest rock as well. All right. 1750 is 2776. Now, if this actually increases as I hope it does, then we've solved it essentially. Then we have to do some modular arithmetic or whatever. So to the next level, we get an increase. So 5528 take away 2776. 5528 take away 2776. So it's an increase of 2752. And then the next one is 8280 take away 528 2752. Nice. That's the cycle. Now put all this together. We need to find the formula, and then we can do it for like a trillion without having to simulate anything. All right, so what am I trying to do now? I've got some numbers. At 2776, so at 1750 we've got 2776, okay. All right, so starting from 1750, got 2776 rocks. Okay. So I need to keep increasing by 1745 until we get past 1 trillion. How many is that going to be? One, two, three, 1, 2, 3. Zeros. 1, 2, 3, 1, 2, 3. Divided by 1, 7, 5. This is that huge number. Alright, I need to make some need to do some arithmetic here. So we've got A equals 1750. Num rocks increase is 1745. So when just put all these numbers here. So now got a trillion. Target equals 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Target is that. So intervals equals target divided by 1745. Let's just print that. It's that. What is rocks plus intervals times rocks increase, and that. We just need to arrive at trillion, but skip a few. Just over 1 trillion. So say subtract 1. 99998,995. So if we do that, the number of rocks. Okay, we're getting somewhere. So final rocks equals that, and final height equals now that will be just short of trillion. Let's try that out. I think I'm going about this in a long-winded way. There's probably something a bit smarter using modular arithmetic. So at that, so we're confident at that many rocks, no, that many blocks, rocks, it's Tetris pieces, blocks. That's what the height will be. We need to push it just a little bit further. So the gap is target minus final box. 1005. So actually, all we need to find is what the height will look like after 1005. More blocks have been placed. And it will be that plus this huge height here. So how do we get that? So we have to simulate 1750 1750 plus 1005. Hang on, so let's stop printing this stuff. Print resting rocks. Resting rocks at highest rocks 1. Just do highest rock for now. You can add the 1 when they actually want the result. What's happening now? Okay, take that out. So 2755. We've got 4362. So isn't that just, so we just, okay, we're kind of doing some of this manually, whatever. So 4362 minus 2776. That is the increase from 1750 to that. Add that to that. I don't know. I've done too many random things now. So it's that, probably plus 1 though. Let's just try it. There are a few errors that could be made here. This is along the right lines though, so. My god, that was actually right. Those last calculations were a mess. I was just writing stuff. I knew that any number of these lines could be wrong. I can't even looking at that, I can't even understand what those last few lines even meant. I was even giving terrible variable names as well. So. Funny hell. How hard? No, that was part 2. Part 1. Part 2 was basically do part 1 but with a trillion instead of 2022. So for the part 1, I just had to simulate the whole Tetris thing for 2022 cycles. And then for part 2, they were like, now do it for a trillion. So you can no longer simulate the whole thing. You have to spot the cycle. And it's clever because the cycle, it's not clear what sort of cycle you're looking for, because you want to find a point at which everything resets and it looks as if it's just a horizontal board again and there's no Tetris pieces. Obviously that never actually happens because there's always a possibility for the next piece to slip past on the left or the right. So you've just got to find a point at which it looks like a horizontal line and it just so happens that no pieces ever go to the sides from then on. And that seems to happen at 1750. And at that point you say, now you've got a fresh Tetris board, you're playing Tetris from scratch, and that's where the cycle is defined. And then you just got to calculate how many times that cycle repeats until you get past a trillion. And this code doesn't, as it stands, it doesn't quite just work. I had to slip in some manual steps here, but whatever. So that whole thing took me just under 3 hours. So I spent about an hour trying to make this rotating grid, but I think that didn't actually help me. If I were to just replace this whole thing by what I had to begin with, which was like 10,000, I think it would be fine. It's about cycle finding, it's not about efficient grid recycling. Yeah, it still works, so I don't think... it's nice to have it anyway. So what it is, for some reason, if you go under a grid of size 80, then they do actually slip some horrible vertical Tetris pieces down the sides just to throw you off, so... So, yeah. Now, I still have 16 to do, but I don't have time to do it now. So, probably in the evening, if I can go back to 16 and finish that off, then I'll have caught up for tomorrow. I'm lagging behind. But yeah, that was tough. It seems like this was tougher than yesterday's problem, and I didn't even manage to finish yesterday's problem, but I had a power cut, so that's my excuse. Let's have a look at stats. Oh yeah, so 16 needs to be done. Where's my personal stats? Oh? I actually... Wow. It took me 3 hours to solve that, but I actually got a rank in the top 2,000, so people are really taking a long time with this. Because, like, the last 15, I solved it in just over an hour, and that got me a rank of 1,600, roughly. So, it's actually getting harder for everyone, clearly. And I could have knocked a whole hour off that if I wasn't messing around with the grid so much. It was a good puzzle, I just got really, really thrown off by the indices. I was just making all kinds of mistakes. I could have easily knocked 2 hours off that, to be honest. Time greater than 24 hours. Yeah, that was where I solved it the next day. I mean, I solved it within an hour or two, I think. It's just I only opened the problem the next day. That was probably the day I had a flight. Alright. Well, that was the hardest problem so far. We'll see. I still need to go back and do the elephants one, but I have an idea for how I might be able to round that off, so I think I might be able to finish that. Oh yeah, score is 0 because you only get a score if you're in the top like 100 or something. What was the, like, let's have a look at the times for 17. The top time was within 15 minutes, because of course it was. Top 100 was within 24 minutes, 14 seconds. I finished it? What, yesterday's problem? No, I still have to go back and finish that. Which problem are you talking about? Tetris one? Yeah, I finished it. I solved it, yeah. The only one I haven't finished is the elephants one from yesterday. I solved Tetris now. That was, I mean, it is fundamentally a good problem. I just ran into countless issues because of the way I was coding it. So in hindsight, having a huge grid is fine. That didn't cause any problems. So I should have just stuck with the huge grid and not tried to do the rotating grid. And there's nothing really I need to do differently. It's just not make those mistakes. But the methodology was fine. I had the right idea, and then it was just cycle hunting, which was kind of a manual step. I can't think how you'd do that completely in a completely automated way. So if I were to now give it a completely different input, this code would not work. I had to manually hunt down the cycles and work out some nice numbers. To make it completely automated, that's tricky, because you have to find the right point where stuff is stable. Because you never know when they're going to throw like a vertical Tetris piece down the column and screw everything up. Alright. Well, that took 3 hours and I'm very hungry now. And I'm never going to have time to do this coding game because these advent problems are actually taking me a long time each day now. This evening I'm going to have to finish off 16. I don't want to fall too behind with these, so I'm going to have to carry on with advent 16, and then we'll see if I have time to move on to coding game. When's the last time I even played a video game? Oh my god, it's just coding now. When was the last time I played Layton? 2 days ago, so I probably should play at least a little bit of Layton today, just to keep that going. Alright, well, as always, hope that was somewhat enjoyable, DIJ and Ku. And I guess I'll see you tomorrow with problem 18. But I will try to tackle 16 this evening as well. I mean, after lunch I might just carry on, so maybe I might come back in a couple of hours. Alright, see you later.